Hey, what's up everyone? Welcome to my channel. This is an ESP32 microcontroller right here, and it's on the S3 dev board to be specific. For this one, I just use the COM port, connect it to your computer, and I use Theoni for a development environment. And you can write code, push it to this board, and then it'll do what we tell it to do. So this project specifically was a socket programming project. And when you have these boards, I actually have a couple of them, but with these boards there's several ways to communicate with other electronics. And in this specific project, we are connecting to an existing Wi-Fi network and then hosting a socket at a set port, and then utilizing another computer to communicate with this board through the network. This panel back here is a Max 7912 LED panel, and you can see there's 4 of them daisy chained together, and it shows you what it's expecting each wire to be, the power, the ground, the data in, the chip select, which tells them to listen, and then the clock, which ticks everything forward at the edge of the CPU cycle so that everything moves smoothly and in a predictable manner. And this right here is a power module for a breadboard. You don't actually have to use these wires and these jumpers. With this right here, I know it's hard to see. I'm gonna work on a better lighting setup. As you can see, one of those is 3 volt, and the other one over here is 5 volt, and these two in the center are ground. So you basically just move this jumper. Like if you want to see, for example, you can take the jumper off and then move it over. Well, I think I moved it too far. Alright, yeah. Move the jumper over, and now we would be sending 5 volts to this rail instead of the 3 that it was originally on. But nonetheless, we're not using that for this project. I have the rail bridged in the center because it doesn't connect underneath there. But yeah, it's not been used in this project. We're using the 5 volt in and the ground, and then I'll mention these other 3 pins when we show the programming part of it. Before I turn this bad boy on, because it's very bright, this little white cube right here is a built-in LED, and out of the box that'll probably just blink. For this project specifically, you can pay attention to it. It color cycles when the board is ready. When a user is connected to it, it pulses steady blue. And I've done that just for a visual confirmation that everything was working here. But let's see, we're going to turn it on. Oh, okay. All right, let's troubleshoot already. We've probably knocked something loose. Oh yeah, okay. That little guy's loose. So, this little green wire was loose. And that's the funny thing about using cheap DuPont wires. Sometimes you run into that. But anyway, so the board's powered on, just so y'all know I'm not doing nothing funny. I'll turn it back off. Yeah, you can see what I mean now. Because like, so this Max panel has male pins sticking out of it, so you have to use a female plug-in. And originally that wasn't a problem because those go... they're female to female wires, and they're expecting these pins to be exposed. And what I was talking about with this board, don't shove it in a single breadboard like this. I've done that. It's probably going to spend the rest of its life attached to this board now because those pins are pretty stuck. And as you can see, the problem here, there's no way to use any of those pins along that top row now, with this being like this. If I'd had a second breadboard, I would have bridged them between the two, which is the right thing to do. That way you can still, you know, have an extra row available, or column, or whatever you want to call it, for to be able to access the pins on the outside. But yeah, anyway, regardless, cheap wiring. My projects will improve over time if the channel takes off. You turn it on, sometimes you get a little weird artifacting. And it's gonna, okay, I'm about to say it's gonna make me a liar again. So it's running our testing message. And now, this is how we're gonna communicate with it. So this is the folder on my computer where I have backup files. Um, that's all that is. That's a backup. This is the one that's actually running on the board. And then our desktop client. So here's how we're going to run this. Open it in the terminal. And it's a Python program. So we need to tell it Python and enter the address where it's at. And you can use a local address since we're already in the folder. So it knows what we're talking about. We run it, and now it wants the IP address. Now, you can get this multiple ways. For one, when you program the board, you can make it set a static IP. I let my board choose its own IP address, though, and I copied it, so we're just going to paste it right in there. Alright, here's some of the good stuff in the programming that I'm going to show y'all when we switch over to the computer. So the server is going to ask, are you a new user? And there's some security stuff to where even if someone else access this, without this specific program, they're not going to be able to change the message. So we're going to say no, because I already have a test account on here with a dirt simple password. Alright, we logged in successful, and the current message is testing. We saw that. Testing. Just constantly scrolling. And what this application has done when I gave it that IP address is it opened a WebSocket on the computer and connected to the socket that the ESP32 is running. So now we're going to say hello YouTube. And we send our message. Message updated, change again, yes or no. Hey, looky there. Hello, YouTube. Alright, so I'm going to switch over to the computer now, and we will go over the Python code that's running both the server and the client part of this application.
All right, so we're over on the computer now, and you do have to apologize. I swear I'm not actually using a potato for a microphone. It just sounds like it. Um, but that may also change in the future. So what we're looking at here, you can see the example I just did for you guys. This is what I was fooling around with earlier. Um, no, it isn't. Now this is exactly what y'all saw. There's where we copy and pasted it in. New user, no. Logging is successful. The original testing message, hello YouTube, and then goodbye. All right, so yeah, not too much to show here per se, but let's flip on over to Theoni. And what I've done now is the board is off of the breadboard. The microcontroller is off the breadboard. I managed to do that without snapping it in half or breaking any pins, so I guess my solder job was pretty good. At least we have that going for us. But when you first get into Theoni, uh, you may notice that it looks like it's trying to play, but it's not showing anything here. So you may have to configure. Um, I would start here. There's actually a couple things you have to do with these ESP32 boards to make them able to be seen on the computer. Like you might have to have the device driver for one. But try this first, and I'll back up and explain the MicroPython thing too. Um, Com8, and here's actually I'll give away my secret. I use Copilot all the time, so let's just go and clear that out. Um, and I recommend if you guys are just starting or just learning out, or just starting out or learning to not be ashamed to use something like this. Yeah, it says PowerShell, but it should still work for command. All right. So COM8 is the USB serial device. Um, Here, I don't care to do it real quick. We'll reach over here and unplug this bad boy, and then we'll run that again. And yeah, it's gone. So we know for sure that this is the device that Windows is detecting. I just plugged it back in. It should show. Might make me a liar. Yeah, so it's there. Um, so that's just a neat little trick if you get into a spot, and I don't feel like there's any shame in searching the internet for help. You can also search the driver that's needed to be installed in order for Windows to be able to pick up on that board and recognize that something's there. Because I seriously doubt your computer is going to automatically prompt you to when you first get one of these boards. But once you have the driver, if you get multiple ones of these boards, like it should recognize it from then on. So we configure the interpreter. I'm going to go ahead and stop it again because I think it said soft reboot. Yeah. So soft reboot. It's running. There's my IP address. Big deal. Um, Let us look at some of this Python code now. Ouch. What are we doing? That was weird that that dropped that in just for me clicking. Oh my lord. Back to the top here. Home. Why are you doing this? Oh, control home. Okay. We'll figure it out one of these days. Alright, so with Python, and that's something else I should back up and explain actually. I'll show you on my desktop. You ever see how lame it is? This little doodad right here. It says Arduino Nano. Doesn't matter. You're going to want to install the MicroPython. And it's not going to do it because my board's running right now, which is great because we don't want to redo that again anyway. So, the great thing about Sione, once you have the MicroPython flashed onto the board, rude, you can look and see what's actually on your device. So it mainly will drop this boot.py file just to have the bare basics on there. And then this web REPL, if you enable that to start and set it up, then while the ESP is running, you can go into your browser and see the console feedback, like, our print statements and our code and whatnot. Why did I? Oh, okay, it opened anyway. The Max 7219. This can be found on GitHub, and I will try to provide the link for that if I don't forget. But what this is going to do is allow us to communicate with that Max LED panel, and it's basically wrapping. From what I understand, it's wrapping the C++ libraries. That way, we don't have to fool with it, and we can instead use our Python code, which it does eliminate some of the flashy animations. And what I mean by that is, let's go. Yeah. See, I was initially going to do, and this was my initial attempt to use a captive portal, but man, that just ended up being a total mess. I wouldn't even bother with it. These are, yeah, the sprite definitions. So you can use the actual hex code to define different ones. Like this is a gobbling Pac-Man animation. That's a ghost being chased by Pac-Man. And I thought I had so many more than that, but maybe not. I feel like that catalog has something to do with it. But anyway, yeah, C++ code. Do not like it. Do not recommend it. To each their own. Like I said, I'll throw the GitHub in there for that. Go away. Go away. Please go away. Okay. All right. Back to the main PY. So NeoPixel, that's a library for flashing that built-in LED light on the board that was color cycling, or when someone connected to it was pulsing blue, that's all NeoPixel. Network library is used for, I think you have to have the network library to be able to use the sockets, and you got to pull them both in. Unless maybe that one was the one for connecting to our own Wi-Fi network. I'll show you through the code. The time library is used to put in preset delays. That way, nothing gets like caught in a loop or anything. Because sometimes when you're doing electronic projects, the hardware needs a minute to think about it. So that's what the purpose of that is. And then I did the same thing with threads. I brought them in here just to make sure that nothing like, two people trying to fit through a door at the same time doesn't always work. JSON is where we're storing our stuff. Oh, I'm pausing that before I'm done. This is where our username, and you saw my password was pass, PASS, but this program hashes it and stores it. And then when the user provides it from the client app, first it's encrypted, sent over the network, decrypted, hashed, compared against this value. And if it doesn't match, then I put in the wrong password and I'm kicked from the server. And that was like the safety part of this requirement, the security part. And then just some other ones I created. But it's important to hash passwords because, as you see, if you've got physical access, you can open this file. And we at least want to make it a little bit more difficult for them, right? So this is where we set up our hardware stuff. The pins that I was talking about, and it was actually the serial clock pin that was disconnecting. And that pin tells the board to listen. It's active low, meaning that when there's no power going through that pin, it's active. So it's telling the board to listen, and that's why we saw no display out, because it was listening and there was no data coming down the data line or anything coming, I'm assuming nothing coming down the clock line. So yeah, that was that. But again, with the Chat GPT thing, you can ask it what pins are recommended for this, and you may have some trial and error there. Another good reference is to go back to the card that comes with your dev board and see, well, which ones of these are capable of doing Mosey, master out, slave in, or which pin would be good to set as the clock pin. And, like another thing, the built-in one with the NeoPixel, this board does not have a 48 on it. So this 48 is what the manufacturer decided would be referenced to actuate that light different things. Like, it doesn't have to color cycle. You could pick any of these colors and just set it to that constantly, pulse it, blink it when an action happens. I mean, they put that there as your way of getting some type of visual feedback from across the room, because this light's very bright. But visual feedback that something's happening, that the board's doing something. All right, I don't think there's anything. Another important thing, like I always set the brightness here so it doesn't burn it out. Now with our Python code, we're setting some global variables here. This one was important. Is the connection active or not? Because remember, if it's not active, we want that light to cycle through all the colors listed in this array. And if it is active, then we only want it pulsing blue and going off. That way we can tell that someone's connected to it, even if they're not changing the sign yet. This is the variable where the message is stored after it's received and then decrypted. And there's another part to that I'll show you down through here that's very important. Another basic security thing is the Caesar shift right here. So the Caesar shift, like, it does not work like this. But just picture looking at your keyboard and say the L key. And let's say we wanted to shift it 4 values. So you go K, J, H, G. So if I sent an L, it would actually come through as a G. And that's a very, rough way of explaining it, because it actually has to do with the order of the ASC characters and stuff like that. But anyway, by putting in a value that only we know and then putting that into the sister program as well, let's say somebody created a new account, well, this Caesar shift is going to make nothing but gibberish come through. And I actually have one more door that's going to stop somebody from manipulating our sign that's not supposed to, you know. So the LED loop, this is that built-in one. If connection's active, then there's the values for blue, and there's the values for off, and then the sleep gives it a little bit of a delay so that it's not flashing erratically or anything. And then otherwise, you know, cycle for color in colors, cycle through all the colors list. Here's that cipher I was talking about. And my brain actually went full retard for a minute there, and you never want to go full retard per Tropic Thunder. So this is the Caesar cipher, and what this is going to do is for each letter in text, it's going to check is it alphanumeric. Um, if it's capital A, then it's going to have a certain value, or if it is lowercase a, then it's going to have a different number value, and that has to do with the USC2 codes and how that low level manipulation is done. But basically, let's say A is 26, capital, but then lowercase a is like 56. So by doing a modulus 26 operator on this, it cycles it through the 26 letters of the alphabet so that it just constantly loops back around. And then our shift that we're adding is, you know, you can choose any number besides 6. You can make it 100, you can make it 5, 1, you know, any shift of values that you want to do. That's how many times it's going to move it and change it to a different value. That way when we return result here, it's not what was entered. It's an encrypted value, you know. And then here's where it's decrypted. The same deal. It's going to be subtracting the shift off to try to put everything back in the same place that it was initially. Then the password handling. So this is what I was talking about where we hash it. That way a user can't just pop open that file and see it. Because we want to make it a little bit more difficult on them. And although Copilot is very useful for things, you'll quickly find out that it's going to recommend to use Hexadigest, and I actually found through a different Google search that MicroPython does not support Hexadigest. You have to do it this way because of the hardware we're dealing with here. Now, I think if you were using just straight up Python on a computer, I don't think you would run into this problem. But if you do, I would just use this uhashlib because it worked great for me. And y'all saw that it was hashed, so it's clearly effective. This is where we check for existing users. You know, when someone signs in, it asks new user, yes or no. So if you say yes, then this is the flow that we're going to be going through. And I'll show y'all where that happens. It's going to open this user's JSON if it exists. If it doesn't exist, and this is the first time it's being run, you know, if you go through the load users function, you're going to get kicked from the server anyway because there's nothing to load. But initially, when somebody creates a new account, if this file doesn't exist, then it's created on the spot, not something that they're going to have to, or the developer's going to have to manually create before time. So that's something to keep in mind. And I included that in my comments for anybody that wants to go through this or maybe even replicate this project. You know, it could be done a million ways. I did it this way because it was part of an assignment and authentication was part of the project. So that was my way of including that. Now, if a user says that they're not a returning user, this is where they're going to register. And this function is past the username and password that they've already entered. And this is the client, or no, I'm sorry, this is the server program again, by the way, if anybody's forgotten that. I know this is making it to be a very long video. So we're going to load the users. If the username is in the users, great. Return false because we don't want to register somebody that's already in there. So the way that that's wrote further down the line, that's going to lead you getting disconnected. Invalid input. Otherwise, take the password that they've entered, compare it, or hash it, and then store it. So return true. They were successfully registered. If they're coming back, they're logging in. We're going to load those users, and then we're going to take we're going to hash the password that they just gave us, and then right here we're going to compare it against the one that we have in that users.json file that's living on the board. If they get if they entered the wrong password or their user didn't exist or anything like that, then yeah, you're terminated. You're out. So here's where we set the board for its Wi-Fi mode, because these ESP boards have different modes. You can actually use several of these to build a long chain of ESPs, kind of like a mesh network, or if you want to do any kind of like encrypted long distance communication, or you don't even have to use the built-in Wi-Fi stuff. Honestly, you can connect it to like 2.4 gigahertz modules and do that low. It's called LoRa, long range. You can do some of that. There's ELRS. There's all sorts of different protocols we can get into. But for the built-in Wi-Fi one, station mode tells it to connect to a Wi-Fi router that's already in existence. If we set it to access point mode, then we're telling it to host its own network, and in that case, we'll give it an SSID and a password versus just passing the WLAN one right here. But you can look up ESP32 Wi-Fi station, and you will find this code all day long in C++ or Python. I included a nice little message just to let it print to the console. And this was something I'd done in case we have any problems and it doesn't want to connect right off the bat. It'll try for 15 seconds. If that doesn't work, it's going to slap 5 off. It'll try for 10. It'll try for 5. And then it's going to hit 0 because the timeout is now going to be below that. It's going to say Wi-Fi failed. Otherwise, I guess I can go and start the board back. I do not mean to keep saying either. Oh goodness, what was that? Huh. Well, that was weird. Huh. My board is totally misbehaving. Now y'all can't see it, but I can. It's probably because I took all the pins off of it. Hit reset, reboot that bad guy. Anyway, while it's doing its thing, yeah, it's cycling the colors now. So now we would probably need to start and play it again. And yes, we're back to listening to it again. I don't know why it's misbehaving. It does that sometimes. Good thing for the reset button, right? So we've connected to my home network. We have the IP address that we can copy and paste in the console in the sister application. The timeout, which you can also set something called a watchdog timer, and that's something that you can do to make the board reset if it does get hung up. But I figured for this project, for simplicity, that was not necessary. We will visit that in the future, though, because that's a very important concept, bringing microcontrollers into electronic projects. You wouldn't want it to hang up if it was controlling like a servo or something really important. Let's say it was running an oven. You would not want it to get caught in the loop while it was managing your oven. So we print the IP to the console. And I wrote 2 different functions initially here. So this is the simple one. It would scroll it 1 time, and that's all you get. But if we come down here and we set it up as a while loop, then if the current message is not equal to the previous one, set the current message to the previous one, and then divide it up into the 8 pixels and feed it to our function, or feed it to our panel, rather. We set it to 0, that clears it, and then display.text, there's where it's going to change it to the new message and start cycling it. Now, for my project, this was the meat of what they expected, the whole socket server thing. In Python, when you tell it global right here, you're telling it to use those global variables instead of creating new local variables, because we want like a single place of truth. be able to be read from anywhere, manipulated, but not existing in multiple copies. So we create a TCP socket on IPv4, and you can find that online all day long. And this was a problem that I ran into with this board. So you would run the test, you'd keep restarting it, run the test over and over again, and eventually it just stopped working. Kind of like it did just a minute ago. Y'all weren't able to see it, but it hung up on me, and you can see down here it wasn't quite behaving like it should be. And this was a way to fix that. It allows this socket to immediately be reused. We bind it to listen on all interfaces, and we can choose that port. It can be any value, but usually they say go over 5,000, and I believe less than 10,000, if I'm not mistaken. And we only want one person connecting to this board at a time because it's only meant to store one message, and that's the only purpose. So if multiple people are connecting, then that's just going to cause a problem. And maybe one of you Python gurus can figure this one out. Look at this. Let's see. It printed the IP, right? That's print. That's in yellow. And it printed white. Why here print yellow? Why did that print in red? Anybody know? Comment on the video. I'd love to find out. Maybe you can educate me. So, yeah, not skipping anything. All right. This is part of that socket still. And you'll see this trip when I rerun the console here in just a minute. Here's the loop for getting the prompt to the user as soon as they've connected. Everything is sent as an encryption, and everything is received. Everything is decrypted as it's received. That way, if you don't know the Caesar cipher and you're just trying to communicate with my board, then it's not going to make any sense. It's going to be jargon. And I'll show you here in a minute where you're going to get kicked off of my board in this project. This board will not stay in its current configuration, especially since I freed it from that breadboard it was stuck in. So it asks, if you're a new user, if they chose yes, then if that function returns true, great, we'll keep on going. If that function returns false, then it's going to print it was not successful. It's going to go on and say that the username already exists because that's most likely what happened, and it's going to close your connection. Sets my LED light back to continuous color cycle versus just pulsing, and we break out and continue. Otherwise, registration was successful. So if registration was successful, then it would not go through the login flow. But if they had chose no, then it would hit this else. It would do the login flow. It's going to make sure that the username and the password comes back true. If it comes back false, so if not true, then it's going to send invalid credentials. It's going to close your connection, and you're gone. Otherwise, you're good. And I realize this probably could have been broke up into smaller functions, but I was on a roll. It was going great, so I figured let's just keep it going, right? The main message loop for updating the matrix. Here's a neat little thing. So it goes on ahead and encrypts and sends the current message to the user so they know what it is in case they weren't actively looking at the panel. I guess you could theoretically do this remotely if you wanted to set up a few more things. The sister program knows that when this message comes, enter a new message to display. There's a code that says if contains this, then it needs to append this tag at the start of it. And the reason for that was, let's say you was able to get into my sign, you created a new account, so your username is going to be jargon because of the Caesar shift, but it's still going to let you up until this point, It's still going to say, what do you want to change the sign to, basically. And when you send a message, it's going to be scrambled. But here's why I added this. Because if it doesn't have this MSG, then if the message starts with this, then decrypt it, skip 4 spaces, 1, 2, 3, 4, decrypt it, accept the text, clear the display, and ta-da, send that it was updated. But if it didn't include that, so else there was an error in the message transaction, sends that it's an invalid cipher, and sends goodbye. And now in the other code, there's a if contains goodbye, reset the loop, close the program, it's over, close the socket, time to run the program again. So now, before that loop finishes, on the lucky chance that everything worked and you wanted to change it again, you could immediately change it. Let's say you sent a typo or you wanted to add a smiley face or whatever. So if the response is not equal to yes, then goodbye. If it is equal to yes, then it would go all the way back through that loop again. It would go all the way back up to here, I think. Yes, here. So that's the result of that. And last but not least, the main loop, and this is where you'll need to change it. Enter your Wi-Fi that you have that you want the board to connect to, your Wi-Fi name, and then the password that you use to log into that network. Um, Otherwise, the board will not be connecting to your network because it would be the same as trying to do it from your phone and not knowing the name or not knowing the password. It's doesn't gonna work. So give the board a second to think about that, and then we start breaking into new threads. I did all 3 of these in a new thread just to make sure nothing got hung up or anything. Now I will show you the client program. Let me make sure I don't need to cut anything out. I don't think I do. Now, because my computer's already hooked to the network, so again, the shift is 6 with the Caesar ciphers. I could have stored that in a global variable. I just didn't feel like it. But the encryption, the decryption, it's the same as the other program. And then main, here's where it tells you to enter the IP address. It strips off that blank. The port that we're expecting to connect to. There's the computer socket that's being created. It's connecting to that ESP IP that we're punching in on the port 5001. It prints successful if it is, otherwise it says connection failed. Now, the server could potentially send multiple things, as it does in some of my error flows. So without having this little wait for prompt thing, it was getting caught in a loop. So that was the purpose of this right here. While true, message receive. If not, break out of this. If the message ends with that, then return what the message was. Basically receive several things and then return it all at once. And then, break for input. So this receives encrypted messages from the server, handles the disconnects. That's where we're decrypting the incoming data, printing it to the console. All outbound messages go through the cipher right there. Send it. And this is what our loop is doing. It's just waiting for a prompt once we're connected. If it doesn't have goodbye or connection error, if it does, then it's going to break. You're going to exit out of that. And then concurrently exit out of the program as well. This is what I was talking about, and you can take the time to read all this if you want. That's what trips. If enter a new message to display is in that incoming message, then go ahead and print the text, enter message to scroll, add this tag, and then the text that the person's entering. That way, the sister program, the server, knows that it came from the right program and it's not some hacker or something. So if it starts to change again, then prompt the user, would you like to change it again? Yes or no. And then they send their reply. And yeah, that's the greatness of it there. So let's go on and show y'all again. I'll show y'all how it behaves in the console. Oh, yeah. I'll show y'all registering too. Oh, hang on. I might have to. Let's not make it. Oh, I did it again. I done the same thing when I was presenting this for my actual college project. Yes, yes, it's a new user. I'll never remember that. This is the only time it'll be used. So the current message is testing, and I actually don't even have it connected to the panel right now. But and we can go back to Theoni, which is running the program, and yeah, you can see that a client connected from this IP address is my PC that we're just sitting on right now. So yeah, the port that it connected to show the input coming in. There was the message that I sent and the tag that was included. So that should wrap everything up. Check out my GitHub if y'all are looking for the code to replicate this, and let me know if y'all have any specific projects y'all would like to see brought to life. I'm planning on getting more breadboards and more components, and hopefully we can all learn something exciting together. Hope y'all enjoyed.